Okay, yeah, so I'm going to be presenting on functional programming in JavaScript. Just as a quick, good idea, I guess, for me is how many people here are, familiar with functional programming, the paradigm, and, okay, so, maybe half or so. Okay, how many people have experience using functional programming paradigm in JavaScript? Okay, cool. Are there any other languages that people use, like functional languages, or experience in that? Oh, cool.
I haven't played with it much yet.
Okay, cool. Yeah, so, okay, it should be good. It's going to be a little bit hard because when I was preparing this, I was like, I don't know what skill level everyone's at, and so it's kind of like a broad range, so hopefully everyone can get something from it. Just a little bit about me. I'm a developer over at Slingshot. It's like a 3-year-old startup down in Orem. So I actually just moved up from Cedar City in January. So I've just been programming there for a couple months. So most of my experience has been in JavaScript for the past 3 years. Like a year and a half of that's been in React. So that's what kind of got me into functional programming, is there's a lot of functional stuff in React with state and mapping and whatnot. So then obviously Node for server-side code. Dabbled in Kotlin for Android dev, and then Haskell as well. I studied for probably 4 months or so. Just after I started getting into React, I was like, man, I want to kind of dive more into functional programming and kind of figure out what it is. So I went to a pure functional language in Haskell, and the place that I'm at right now, we're converting, everything's in Ruby on Rails, and so we're converting that over to React and GraphQL for the server. So I've got a little bit of experience in that, and then I've been pretty interested in algorithms and machine learning as of lately, and then I've done a bit of HTML game dev. So that's kind of my contact info, but we'll go ahead and get going. So this is the Wikipedia definition of what functional programming is, and as always, it's pretty I guess what's the word? Complicated. Basically, it just says, in computer science, functional programming is a programming paradigm, a style of building the structure and elements of computer programs that treats computation as the evaluation of mathematical functions and avoids changing state and mutable data. It is a declarative programming paradigm, which means programming is done with expressions or declarations instead of statements. In functional code, the output value of a function depends only on the arguments that are passed on the function. So calling a function f twice with the same value for an argument x produces the same result, f of x, each time. This is in contrast to procedures depending on a local or global state, which may produce different results at different times when called with the same arguments but a different program state. Eliminating side effects, i.e. changes in state that do not depend on the function inputs, can make it much easier to understand and predict the behavior of a program, which is one of the key motivations for the development of functional programming. Okay, so it's quite a bit, and after that you might kind of be like, okay, what the heck? What exactly was all that? What I'm going to be talking about today, and I'm going to try to not kill everyone death by power slides or whatever. So I have some live coding that I'm going to do, and it's some examples from a project that I built. But we're going to break it down into functional programming can be broken down into pure functions, first class and higher order functions, immutable state, referential transparency, lambdas or lambda calculus, and then in JavaScript, some of the key ways that functional programming is used is on the array prototype, map, filter, reduce. And then we have recursion and currying. Is there anything on there that is there anyone here that's everything on there is yeah, I know exactly what all of that is? Sort of. Okay, we have one. Okay, cool. That's good. That means everyone can learn something, I guess. So can someone give me, I guess if I could have someone read pure functions, and we could talk about what pure functions are exactly. Could I have maybe a volunteer or someone to read those two things? Okay, perfect, thanks.
If a function is called with the same argument, the result will always be the same. No side effects occur inside of the function.
Okay, so this is one of the main concepts of functional programming, is the idea of having pure functions. So just like what he read, what goes in, if you pass in the same arguments into a function, then it should always return. So for example, if you're using a random like number generator or anything like that inside of a function, then technically it's not going to be purely functional, because if you return a random number, if you call a function and you return it randomly, then it can have the output differently every single time. So a couple examples. This function here, this sum function, is a good example of a pure function, because if you pass in 2 arguments and you return them, this will always return the same output. Does anyone disagree with that? Or is that, I think that's pretty readable. So like if we put in sum and then we instantiated or invoked it with 5 and 4, then we know the result is always going to be 9. Whereas an example of not being functional is if you take state outside of your scope, and if you're to modify it, like in this function down here, this is a good example of what is not a pure function, because you're going outside of your scope and you're modifying state out. Does anyone know why this is like such a big deal? Because like I'm sure most of you guys that have been programming for a little while have like noticed that functional programming kind of has, like in the past like couple years, has kind of like exploded onto the scene, and a lot of programmers, it's like one of those buzzwords or whatever. Is there a reason? Were you saying, is there a reason why? Do you know why?
My background is not Java. I'm C# programmer, and functional programming has become important because they've added the Lambda, where you can put insert a unnamed function anywhere in code, and it's function pointers. It's something that's being added to logic languages that makes it really easy to add a function anywhere, and it's very useful.
Yeah, so that's one reason. There's another reason. What were you going to say?
No, I just have a quick question. I might be wrong, and actually I'm glad that I'm seeing this, because I wasn't making the wrong assumption. The cons were create a specific scope. Basically, when I run that in my head, I see the console telling me C has not been defined, because to make it work, I need to put a bar instead of cons. I don't know. See what I mean? So in this example, you're using cons, and I don't know, I might be wrong, but as far as I understood when I was reading the documentation, it says the cons, it has its own scope. So I might be wrong. But I think that C, in this case, this function might not be able to modify C, because since it's out of the scope, when you run that you're not supposed to run that, the browser or the compiler might tell you that C has not been defined. Okay, so I understand what you're saying. Did you have something that you wanted to add?
I know that function cannot be tested.
Okay.
Yeah.
Okay.
Divide it.
Okay.
That's a great answer to your initial question of what's the problem with the pure function,
Yep.
not with a non-pure function. It's
Testing.
hard to predict its result.
Yep.
Without having a set value of Z.
So like you're saying, you wouldn't be able to do like an assert function or like test it through asserting a value because it's changing. That's correct. Did you have something in the back?
No, it's good.
So back there.
I think one of the issues is that it introduces global state.
Mm-hmm.
And then once you have global state, it's really hard to debug and kind of logic through what's going on.
Yep. Yeah, so this actually, to answer your question, this would work because it's above the scope. So they're both, this function and Z are in the same scope, so I have access to it, correct? So this would work. The reason why it's not purely functional is because I'm going outside of my scope of that sum function and modifying Z.
So Z is in scope, but it's in scope because it's in the parent scope.
It's because the example that I saw one time, they have like a Z, and then they give a value to C, then they modify C inside of a function, and then they console log C after the function. Mm-hmm. And both of them have different values. And that's the only reason why I was saying like that, because I don't know if you ever see that example when they say, see, it didn't modify because it's out of the scope. And this one, using the word cons. But yeah, it makes sense.
Yeah, so the reason why, are most of us like using ESNext syntax, or are we, most people using like ECMAScript 3? Okay, so like const, the difference between const and let is const is really valuable in functional programming because once you assign it, it's known as like, okay, this is just like in other languages and how we used to in JavaScript where we just capitalize everything and we're like, okay, this is immutable, you're not going to change this variable. This is what's constant. They both have the scope, the new scoping done to them, but lets you actually modify the variable. So one of the things that I try to do in my JavaScript is I pretty much always declare every variable or function with const, unless I'm going to be modifying it. And then if I'm not practicing functional programming, then that would be breaking it. Any other questions about this? So going back, okay, go ahead.
Just to be clear, the bottom function will modify Z.
Correct.
And it'll be different every time.
Yeah, well, depending on what we pass in as parameters here. So if we passed in 5 and 5, then Z, we just set this Z out here to 10. And so going back to the original question, the reason why functional programming is becoming so big is because with computers getting bigger and having multiple cores and being able to run on different threads concurrently, this would be really bad if my code modified this, but you were running the same thing on another concurrent process, and you were expecting Z to be something else, but I came out from under you and just changed it to 10 or whatever I wanted. So this is why functional programming is becoming so big, is because in the future, we're going to start taking advantage. Right now, most of the time, we're not taking advantage of concurrent processes running, but in the future, we will. So that means faster code and everything, because everything's going to be ran in parallel. Any questions?
Even with JavaScript's single event loop, you can have challenges with this sort of thing. If you say you have a const sum that's written this way, and you have another that's const subtract that subtracts x and y and sets z, another one that's divide.
Oh, yep.
And these things are all of these functions use that same z. They modify the same global state. You don't necessarily know which of those functions was last called.
Yep.
And this is one of the things that React and other functional models are meant to set you up for, is so you have a very clear flow of events. You know exactly what caused what.
You know what to expect. Like when I'm using Z, I know if that's a const Z equals 5, I know it's always going to be 5. No matter what, wherever I use it, I can rest assured. Whereas if we start modifying it, like you were saying, in different functions, and then it gets even more confusing if other files start, like you have like a global state, and then it's like a little bit out of hand. So that's the big reason why functional programming, and like you were saying, like these functional libraries, like React especially, they're big on this because, especially with UI, if you're a front-end dev, you know that most of your bugs in front-end code come from state being, like back when we used to use jQuery and whatnot, it was like, okay, I'll change the state here if you click this, but then, and then I forgot that I'm actually changing it also down the line down here, and so there's a lot of bugs that come through that way. Okay. So next up, in functional programming, functions are by definition to be functional, like a functional programming. Functions need to be first class and higher order. Does anyone know off the top of their head what it means to be a first class function? Yep.
I'm going to go with you can assign a function to a variable.
That would be exactly correct. So who would argue that JavaScript does not treat functions as first-class citizens? Anyone? Okay, exactly. We obviously can assign functions in JavaScript to variables, and we have been able to forever. So that passes the test. And then higher order functions just means that you're able to pass a function in to another function as an argument, or be able to return it from that function, which obviously we can do in JavaScript as well. And there's a lot of code like on the array prototype that we'll talk about later with like map, reduce, and filter that use all of this. Any questions on first class higher order functions? Nothing? Okay. So a couple examples. This one up here, obviously that's letting us assign a function to a name, and then we can invoke that throughout wherever we have scope to this. And this one here, this is actually, it's returning a function, and it's actually doing what's called currying. And what currying is basically it lets you partially invoke functions. So has anyone used this type of syntax before? Yep. If you use Redux at all, then you actually are using it. Like the connect method, you pass in your state, your state and props. That returns a function, and then you pass in your component to that. But this can be, I guess, kind of confusing. But what's really cool about partial evaluation of functions and currying is being able to compose functions from functions. So I'll give a couple examples later, a little bit later, but basically like we could have a function that's like sum5, pass in, or I guess that might not be the best example, but I could do this. I could do const sum5 equals sum and then pass in 5, and then everywhere else in my code I could take this sum5 and then I can just invoke it with another number, and whatever number I pass in will always be added to 5, and then we'll have a new value. So it's kind of cool to like allow you to compose functions from functions and build blocks that way. So yeah. Next up, immutable state. This is really easy. It's kind of what we talked about. Once a variable is assigned, it can't be modified. So you can create new variables from variables, but not actually modify the original state. The map function on the array prototype is a good example of this. But basically, there's a lot of there's a few libraries. The one that I use in JavaScript is Lambda, but they have a really nifty function method on it that's called clone, and you can pass in something and it'll actually do deep cloning. So then you can reassign it and then modify the data. Does anyone know what problems this might bring up performance-wise?
Garbage collection.
Yep. So exactly like when you're doing it this way, you're going to be creating a bunch of new objects, and then if you don't ever use that object that you just cloned, okay, garbage collect, garbage collect, garbage collect. So there's twofold, because you have to go out and get memory to create the new object, but also then we have to do garbage collection. Luckily, obviously, JavaScript handles garbage collection, but performance-wise, it can be a problem, especially in bigger apps if you're doing a lot of this. Any questions on immutable state? Comments? Okay. Referential transparency. I was reading an article recently about this, and I was like, wow, that sounds like pretty intense. It's actually like just a big word for saying referential transparency allows us to replace the value of a function call with its return value everywhere that it's called, and the state of the program stays the same. So basically going back to like our sum5 function, that's exactly what this means. Like we can call sum5 anywhere throughout the code, and we know that it's going to be adding 5 to. Or actually, a better example would be to return, like our sum function, like you'll return x plus y, and I could assign, so I could say like 10 equals sum, invoke it with 5 and 5, and now I know that it's going to be 10 everywhere throughout the code base.
So an example technique of this is memoization. For instance, if you have a redux selector where you're selecting state out of it, and because if that selector is a pure function, so on it, if you pass it the same set of arguments, you'll always get the same result.
Yep.
You can do an optimization where instead of recalculating what you're selecting, and therefore building a new object and doing all the memory and garbage collecting that we just talked about, you can return the same object you had before, and now your updates will or will not happen based on whether or not you have the same thing.
Yep, exactly. Perfect, thanks. So actually, I guess I have an example here. Anywhere the number 8 is being used throughout the app can be replaced by add numbers, essentially. And so we can guarantee that this function will always be returning the same thing. But yeah, if you want, I used to work with this developer back in Cedar that he was all about the big vocab, but didn't actually know what any of like his terms meant, but if you want to add one of those to your vocabulary, referential transparency is a good one to make you feel smart. Okay, last one I think before we'll do a little bit of live coding is Lambdas. This is actually the base of functional programming, is Lambdas calculus. So if like when you're studying Haskell, this is a big thing in any functional programming. But essentially, for our purposes in JavaScript, it's like quite a bit more complicated than this, but it allows you, like someone said, like with anonymous functions, being able to pass them in and like who was it that was talking about like C++? What was this when you were talking about? Yeah, so a lot of languages, like I know C# didn't have this for a while, but recently, in the past little while, they've added. There's a lot of these languages are starting to add it because it's really helpful to be able to pass in a Lambda function throughout your code. Okay, who uses map, filter, and reduce? These are probably the most common JavaScript functions. A lot of people. Does someone want to give me a definition of what these functions are, or methods are, what they do on the array prototype? Yeah. Okay, cool.
When you call map on an array, you give it a function, and then for each element in the source array, it will call that function, and it hands you back a new array with the result of having run each of those elements through the function in the same order. Filter will hand you back, you can give it also a function, it will hand you back an array. It will take all the elements in the source array, run it through the function. Any of them that return truthy, you get back as the return type. And reduce, how would I explain reduce?
Reduce is the grandmaster.
It's a way to turn a collection of things into a single value.
Yep. So can you use reduce to accomplish anything that map and filter can do? Yes. Do you have to reduce down to, if I pass in an array, a reduce off of an array, do I have to return an array?
No.
Nope. You can reduce it to anything. So this is like, if you're going to learn, if you really want to learn something new, if you aren't familiar with these, reduce is super powerful. You can modify data however you want. So with that, I'm going to do a little bit of, oh geez, how do you get out of this? Okay, a little bit of live coding examples, just real quick, of these methods on the array prototype. Is that big enough? Can everyone see that, or is it?
It might be worth making it a bit bigger.
Okay, well, good luck on. I've just been into, like, just started using a Mac.
Oh, if you press Command and the plus key.
Oh, it's Command plus. Okay, perfect. Thanks. I should probably know that. Thank you. Okay, so I have an array of players. I'm like a pretty big basketball fan, especially Jazz. So if anyone's like a Jazz fan, you'll recognize some of these names. But regardless, we have a players array with 5 different items. It's an array of objects. We have IDs, names, and height. So this is something like in React, if you're familiar with React, you'll use map a lot on arrays to like do list items or to render multiple things that way. But you can kind of think like you'll use this all the time. Like if you go to the server and get back a bunch of data, oftentimes I'll use map to like reduce it down to what I actually want. So a good example of using the map method is we can get all player names by doing players. So all of these methods, they're on the array prototype, which means anywhere that you have an array, if you guys like are familiar with like prototypal inheritance, but you'll have, it's basically like classes, like it's a method on the array, so we have access no matter what. If it's an array, we have access to this method. But like he was saying, we pass in a lambda, which in this case map, you can pass it in with multiple arguments. In this case, I'm just going to do the first one, which is the item that we're getting. And then in the function, let's say, well, obviously we just want to get all the player names. So all we'd have to do is say this item, which is the player, I just want to return .name on all of these. So then if we console log this, this should return an array of just Rudy Gobert, Donovan Mitchell, all those names. So if we run that, voila. So obviously, like we're saying, it's kind of cool. if you get a bunch of data back, like if you're not using like GraphQL or something awesome like that, and the server sends you a bunch of stuff back, you can map off of it and modify the data to your liking. Okay, example of filter. So same thing, we'll say we want all players over 6'10", so we'll just say tall players. So what we can do here is we want to return the objects of everyone that's over 6'10", which is 80 inches. Yes, 80 inches. So we would do players.filter. And if you guys have like questions or something, go ahead and stop me. But same thing as map, we can, right here, we can have the item. We can also get the index as a second parameter, but what we'll do here is we need to return a Boolean, and if it's true, then that means it will be added to our array. If not, then it filters it. So what we do is we say player.height is greater than or equal to 80. And then if we console log these, just like that, run it, and those 3 players are the ones that are over 6 foot or 6'10" or over. Okay, now we can actually, what's cool is since both of these methods, they return an array, a new array, we can actually chain on to it. So for instance, if we want to get all player names of people that are over 6'10", then what we would do is we would do we would filter it just like we did up here. So I'll just copy this. So that's going to give us the objects, and now I can chain onto this and call a map and say, okay, now I have those 3 player objects, and I can return player.name. So that should give us these 3 guys, just their names, not the whole object. Sorry?
6'10" is 82 inches.
Oh, you're right. Yes. Okay. What I meant to do is 6'8". Joe Ingles. Good catch. All right. Names of tall players. Okay. And if we run that, boom, now we have an array of just those 3 players that are over 6'8". Not 18. Just like that. Okay. Now this is where reduce. Yeah, sorry. Yep, sorry. Go ahead.
On that last lambda, the .map player to return their name. Would it break from functional paradigm if you just called the names constant from the very first? Said .map names.
Right here.
You already created that as a constant. Yeah.
Oh, up here.
You just reused it.
Yeah, you could.
Okay. Well, would that break from functionality because you're calling something outside of the scope, but without modifying it?
No, because this is actually a function. The names function. You're exactly. Let's try it out. So what we can do is all we're doing here is passing in.
You haven't named your function there. You have a result of mapping over that.
Right here. Is that what you're talking about?
So if you want to name that function,
Because I think what he's saying is if we did this, right?
Yeah.
Yep, we definitely could. So this is.
what is name?
That's a result of a function. But that was an array.
Oh, you're right. You're right. You're right. This. Okay, you're right. It would be this right here if we did this. Does that make sense?
Yeah.
Is anyone code correcting me? Make sure that's true. So that's that's right. I was returning a result. Good catch. This is a function, so then we could pass this function in here as names, and we would pass in here. Map. This is a function names, so we'll pass in name here, right? Or player. Oh yeah, yeah. You're right. You're right. You're right. You're right. Okay, so now with reduce, what's really cool about reduce is we can actually do the functionality of both of those, the map and the filter, just through reduce. So like if we were to do the same thing, this same function here, we could do it by saying reduced tall players, I guess. And now we could do players dot reduce. So reduce is a little bit different. Reduce, our first argument that we get passed in, or parameter here, is the previous value. And then our second one is the actual item that we're working on. So the player here. So if you don't set inside of this reduce method call, if you don't set the second parameter here, then it would default to be the first item in our that we're going over. But in this case, we want an array. So I'll pass in as my second parameter here an array. And then what are we doing? We want all players over 6'10". Okay, so all I do is say if, and here, and I could say player, well, we'll just copy this guy. So if the player is over 6'8", let's change that. Then we want to take our previous value, which is an array, and we want to push onto it, but I don't want to push the whole object, I just want to push the player name onto it. And then we always return our previous value down like that. So now, if we do reduce tall player names, that should give us the same result. So that's kind of cool with reduce. Yeah, go ahead. So that this array on the end, that is our initial value for previous value.
Oh, okay, so it starts with that.
Yeah, exactly. Yep.
So if you had a player name in that class array, it would show up in there, correct?
If I had a...
Just say
oh, yeah. Yep. Yeah, like right here, if I said, oh, I'm a really good basketball player, just like the Jazz players. So, yeah, this would push on. So if we run it now, you're going to have... And I'm also 6'8", by the way. So...
So reduce takes two parameters, right? The callback function you're applying stuff to within
a previous value.
The actual array.
Or initial value.
The value that you're creating with.
Exactly. So that's like that's our initial value. Like this was a good example is you could set this initial value to whatever you want. So what's really cool is like we were talking about earlier is like reducing, you don't have to reduce down to an array like these other like map and filter, they always return an array. In this case, we could return whatever we want. So like for example, let's say we want to do this same thing, but I want to get the number. Like let's say for some reason, well, not for some reason. Let's just pretend that the array doesn't have a dot length on it. If we wanted to implement that ourselves, all we'd have to do is say reduce tall player length, and we'll set that equal to players.reduce, and then okay, so right here as our initial value, I wouldn't set it as an array, I would set it as a number. And then inside of our callback, we'll take this same, we'll just copy this. But instead of push, because this initial value is an array, so on a number there's no, well, maybe there's a push. But what we do is we just say previous val, and then we can add on to it. So now this will return the number of that. So 3. And same exact thing. We could set that initial value to 1, and it would return 4. So yeah. Yeah, so it'd be the third parameter in the callback function. Yeah, and that's a good point. I'll just show real quick. Because oftentimes, like if you're using React, you have to set a key on your list item so it knows when it's doing the render that it basically keeps track of which one's on screen with the keys. Right here, either in filter or map, you'd actually be able to pass in index right here. So in case oftentimes you need that index, and you can do whatever you want with the index. So yeah, good comment, thanks. Did you have okay. Any comments, remarks, anything? Yeah.
So, well, what we were just saying is that map has the third argument of the initial list.
Yes.
And this has a fourth argument.
Okay.
Also the initial list. The other item, just looking at what you were doing.
Okay.
Is the use of push is a mutation.
Correct.
Variable. And Ethan and I were having a little discussion about that and whether we should even point this out. If you wanted to go strictly immutable, you would need to create a new array with all of the values from the previous array plus the one you want.
Yep.
Which we use a spread operator for.
You could. Where would you run into? I ran into this problem. This is a good point, because actually technically what I'm doing here, this isn't purely functional when we're doing this push. But where would we, if we do the spread operator of an array, so we're cloning it, where would we run into an issue? If, let's say we have an array of objects, and I spread it onto there, what would happen? Any idea?
Wait, with the dot push? Or?
No, so this is this way. So he's saying what we would actually do instead of pushing here is we would create a new, I would actually create it up here, but some variable or whatever, and then I would set it equal to an array and take that previous val like that, and that essentially clones it. So now we're back to purely functional. Where I ran into an issue with this, and I'm actually going to show an example of the code that's still like semi-broken. It's off of my Sudoku generator and solver here. I was like banging my head for like hours because I was like, what the heck? That state shouldn't be there because I'm cloning it and it should be changed. This does not clone nested objects. So it doesn't deeply clone it. And I didn't know that. And so I was just banging my head. And then finally I realized that. So that's why I mentioned earlier, like the Lambda library has a clone method, and that will actually deeply clone everything. And I think what's the other popular, Lodash _ any of these. So if you're familiar with those, I'm sure they all have deeply nested.
There's a number of ways to deep and shallow clone, a number of modules to let you do that as well. You can also return that spread directly, but as Ethan pointed out, in this case, you just barely created that initial state, and if you're creating a new array and iterating over the previous array every single time,
it's creating a new array.
That's a lot of, again, garbage collection that you're invoking there.
Yep. So this is the problem with the cool thing about JavaScript is we can practice a lot of these functional things. The bad thing is it wasn't like built to be a functional language like Haskell or whatever. And I'll show. I think, what time am I out of time? 6:40.
There's 20 minutes built in between presentations, so that you can be done if you want to.
Okay.
But if you got a few more things you want to show, you get that.
Okay. If you guys want, I'll show basically recursion. If you're familiar with recursion, this is where you run into a lot of problems. Is, hey, recursion is super cool because I don't have to use for loops anymore. I can just return that function. But the problem is, if you have a massive array, JavaScript isn't tail-end optimized like Haskell or these functional languages. So your call stack, you'll just get like a max call stack error all the time. So real quick, whoops. Let's see here. So recursion, I'll just show an example with recursion. Does anyone know what recursion is, or if they use recursion very often? Yeah, either of you guys.
It's essentially a function that calls itself, preferably with a smaller version of itself.
Yep. Or, yeah, or not, right? Like that, you could recursively call a function and tell whatever that signifier that you're done is done. Like you could recursively call a function to build an array, right? So an example of that, yeah, go ahead.
It's when you have to swear twice when you're writing a function.
Yeah. So what does recursion replace? I said this just a couple seconds ago, but what is it replacing code? When we call a recursive function, what do we normally use in place to get the same effect? Yep, looping through. So here's an example. Like I was showing here, I built this Sudoku generator probably like 3 months ago, and I left it in a semi-broken state, so hopefully it works. Basically what it does is randomly generates a solvable Sudoku puzzle, and then I can click solve, and it'll actually use a backtracking algorithm to solve it. And then, actually it broke right there. Basically though, it will keep generating and then let us solve once I fix the bug. But what I wanted to show is I'm actually using a recursive function right here, this getPopulateGrid. So the main thing with recursive functions is you have to have like an ending statement. Just like in your for loops, you know how your second item in that for loop is the thing that's saying, hey, when this is done, stop. Yeah, the condition to, okay, you need to stop this. So this is actually an example where I'm populating a grid by filling that Sudoku puzzle with numbers. But basically I'm saying, hey, I want to keep calling this function until there's no more slots to fill. And so right here, I go and I get an updated grid, and all I have to do is pass in the new grid here and then subtract. This is just like in a for loop when you do like I++ or the incremental values. But basically this is kind of an example of a recursive function. And then once this grid is fully populated, this grid will be returned, which will be a populated grid, and then where I'm calling this now, you'll see I have it assigned as this is a populated grid, which is just an array of arrays. So it's kind of a cool concept, but again, like we were talking about, it's really cool. I had at the last place I worked at with one of my coworkers, we were talking, and he's like, well, for loops are always faster. And I was like, well, that's true. Even like for loops are faster than for eaches, and for loops are faster than a recursive function, but we were like, okay, well, let's test it. So we both wrote these functions off of a huge array, and we're going to time it with the console time or whatever. And I go to run mine, and then like within like 2 seconds, boom, max call stack error. And so then we found out, obviously, it's the tail end of recursion. Yeah, go ahead.
One of the items that sometimes I face with recursion, because I do not several times, a few times, is that a couple of times I end up with a exponential time due to the recursion. So I have to tweak it to be able to get a more linear time in the execution. Actually, I remember that I wrote in my blog, I put a big blog where I run a very small code using a for loop. Then I use recursion, and I time it and just say like it takes forever. And then I tweak my own function. Basically, in this one I was building, it was very stupid. I was just building the Fibonacci sequence.
Okay.
But eventually I got the recursion to be able to be linear.
Cool.
But the only thing that I was like to be careful with the time, because usually the first one that I build, it's exponential, and I need to go on.
Yeah, so like this with Fibonacci code, if you didn't have in your recursion function like something saying, hey, stop at the number whatever large.
No. Basically, this function was very simple. You just put like a 36, and it's going to build the first 36 numbers of
I see.
seconds. So basically, you basically say call it. When you put a number inside, it's going to build up. If you put 3, it's going to build just the first 3. If you put 1,000, it's going to go for the first 1,000. So basically, but I was timing it, and the recursion. Actually, maybe I can show you, because I put a blog post with all the code. Documented the whole thing for me to don't do that same mistake again.
Yeah, I'd be interested to see, because it's hard to see how that would be like return exponential.
It's in the internet right now. Just if you go to blog.mycode.com website, and you click miscellaneous, and just click the one that says recursion, right there is the code.
Oh, cool. Maybe I'll get with you. I think like my time's up actually, but I'll get with you after this, because I would like to see that. But Cool. Yeah. Any other questions or comments on recursion? Testimonials to functional programming? No. Say it again. Wait, I'm sorry, I missed it. Oh, okay.
In React, if you're not using like Redux or MobX or something for your state management, you'll do inside of the function, you'll do set state. Quite often, would that be violating this paradigm of functional programming?
No. So what React does, the way you'll solve this is you can actually call this.set state and pass in a function. And that in that function you can get a previous value on that callback function. And that's where you would clone that. If you're like modifying an array or something, you could clone that and set state that way by returning the object. So
Would it still similar where it's like maybe I'll call a function that depends on the state of that component, and that function could return something different based on what the state of that component is? Does that make sense what I'm saying? Maybe you have like a checkbox or something that's like a get value function on a checkbox, and it'll return something different based on the state of it.
Right.
I feel like that's probably a good thing to have, but I feel like it's kind of going outside of the paradigm of functional programming.
No, because my understanding with set state, I could be wrong, but I think set state, when you call set state, it's an asynchronous function, but I think it returns a new object for that state, right? It's not modifying the actual state object. So like if you're saying like your check mark has like a Boolean value and you say, okay, set it on and off, I think when you call this.set state, take state, and I'm assuming it's immutable. I actually would have to look it up, but
there are aspects of it that are aspects of React.
Probably for performance, yeah.
Just the fact that you are using classes indicates that you have the component, which is a factory for, I don't even know what to call it at this point, an element. The element has associated with it both function methods as well as element state that it's modifying.
But it allows you to modify the state inside of itself, not like that's the idea with props, right? Like if you have props coming down, you're not modifying.
You're supposed to use functional set state to get an updated state,
right,
and not mutate it. But you can just mutate this .state. You just won't necessarily see that update in your code because React is expecting it to be functional, to be pure on state.
Plus, you'll get a warning error in your console that will say, "Hey, use the function." And so, I don't know. I'm like OCD. Like any of those warnings or errors like bug me. So, anyways, did you have a question in the front row? No. Okay. Cool. I think that's. Any other questions or anything? Comments? Real quick, we already went over recurring. It just basically allows you to partially invoke stuff, which is really cool. And then that's a pretty good show. Anyways, that's if there's no other questions. That's my presentation on functional programming. Oh, sorry.
What's the name of that show?
Silicon Valley. Yeah, it's everyone probably most people watch Silicon Valley, I'm assuming. It's an HBO series, so it's like not super appropriate, but it is appropriate. But for a programmer, it's really funny because everything you go through daily life is like, yeah, I know this Erlich Bachman, I think his name is. I haven't watched it for a while, but it's like, oh yeah, I know one of those guys at my job. But anyways, okay, that's it.